Your phone begins as a flat sheet of glass. Quiet, still. It looks simple, but that simplicity is an illusion. Beneath the surface, a hidden world is waiting. A world made of fields, charges, and invisible structure. Every time you touch the screen, you step into that world, even if you never see it. Under the glass is a transparent grid, thin conductive lines, rows and columns, a silent map of possibilities. Each intersection is a tiny sensor. Each one is ready to detect the smallest change. This grid is the touchscreen's nervous system. Always on, always listening. Every line in the grid carries a faint electric field. Not enough to shock you, not enough for you to feel, but enough for the screen to sense. Think of it as a calm surface of water, perfectly still, perfectly balanced. The touchscreen watches this stillness and waits for something to disturb it. Your body is a natural conductor. You carry electric charge without noticing it. When your finger approaches the glass, you don't need to press. You don't even need to touch. Your presence alone bends the electric field, like a small weight on a stretched sheet. Like a ripple forming before anything touches the water. Your finger becomes a disturbance. In a landscape of electrons, each point in the grid has a property called capacitance. It describes how much electric energy it can store. In its resting state, each point has a stable value. When your finger gets close, that value changes. The capacitance rises. The system feels the difference. This is the language of touch screens. Not pressure, not force. Just a change in stored electric energy. The touch screen scans the grid constantly, thousands of times per second. It checks every point, every value, every tiny shift. When one point changes, the system notices. When several change, the system calculates the center of the disturbance. It finds the exact location of your finger, using nothing but electric measurements. Touch screens can sense more than one finger. Each finger creates its own disturbance, its own ripple, its own signature. The grid becomes a pattern of changes, a map of multiple touches. Pinch, zoom, rotate, swipe. Every gesture is a shape, made from electric distortions. Raw coordinates are not enough. Your finger is analog. Your motion is imperfect, so the operating system interprets your movement. It filters noise. It smooths jitter. It predicts where your finger is going. It decides what you meant to do. A tap, a drag, a long press. A flick. The software turns your motion into a clear command. When you drag a photo across the screen, it feels like you're moving something real. But you're not. You're moving a point in an electric field. The system responds with animations that mimic real physics. Momentum, friction, elasticity. These forces are not real. They are simulations, designed to feel natural. The real world is messy. Rain, humidity, gloves, static electricity. Water creates false signals. Gloves block your electric field. Static charges confuse the grid. The touch screen must decide. What is a finger? And what is noise? This is why touch screens struggle in the rain. The physics becomes unclear. To handle this, engineers add layers of intelligence. Signal processing, noise rejection, adaptive thresholds. The system learns the difference between a droplet and a fingertip, between a swipe and an accidental brush, between intention and randomness. This invisible work makes touchscreens feel reliable. Early touchscreens were resistive. They needed pressure. Two layers had to physically meet. Capacitive screens changed everything. No pressure, no moving parts, just electric fields. And the human body. Modern screens detect hover, pressure levels, stylus signals, and even the shape of your fingertip. The physics is the same. Our control of it has improved. A touchscreen is more than a sensor. It is a communication channel. Your finger sends a signal. The device responds. A loop forms. A conversation begins. Every tap is a request. Every animation is a reply. This is interaction, at the speed of thought. When you touch the screen, you are not outside the device. You become part of it. Your body completes an electric relationship with the grid beneath the glass. You become a participant in the circuit, a conductor in a field of engineered charge. The boundary between human and machine becomes thin. So the next time you touch your screen, remember what is happening beneath your fingertip. A grid of invisible lines, a field waiting for disturbance, a change measured with precision, a choreography of capacitance, a dance of electrons, a quiet conversation between your body and the device. Touch screens feel simple because the complexity is hidden, but the physics is always there. Silent, elegant, waiting for your touch. Thanks for watching, and I'll see you in the next chapter of this digital adventure.